Okay, today we're going over solving a system of equations. So in Algebra 1, you did this where you had two variables, and then what we're going to learn is three variables. So in this case, how this is set up so that it is y equals 5 minus x, that tells me that substitution would be a great way to solve this. So I'm going to go ahead and I'm going to take this 5 minus x, and I'm going to substitute it in for the y. Let me zoom in on that for you. Okay, so what this is going to be is I'm going to have 2x plus 2, that's where y goes, equals 10. But instead of the y, I'm putting 5 minus x. Now from there, I'm going to go ahead and simplify, so I'm going to distribute the 2, and I'll have 10 minus 2x. I'm going to combine like terms. I'm going to get 2x minus 2x cancels out, and I'm left with 10. And on this side, I have 10. When all the variables cancel out, it's either no solution or infinitely many solution. And you look at what's left right here, and you say, well, 10 does equal 10. Therefore, it is infinitely many solutions. Had it been something like, I don't know, 0 equals 10, you'd be like, well, that's not true. Therefore, it's no solutions. So, and what the graph of infinitely many solutions looks like is that it has some type of a line, and the other line is the exact same line, and so they're graphed on top of each other, meaning they have infinite intersections forever. Okay, on this problem, this is set up for elimination method because it has the x's are stacked, and then the y's, and then the equals, and then the number. So when I'm eliminating, what I'm trying to do is get one variable to cancel out. So I can choose either x or y. Y looks easier in this case because the 4y, I need the other one to be a negative 4y. Well, that would be really simple to get that to happen by multiplying times a negative 4. And remember, it's fine to do that as long as you multiply everything in the equation by that negative 4. Okay, so I end up with that. And then my original second equation was 2x plus 4y equals 60. And now I can add straight down. Negative 12x plus 2x is negative 10x. Negative 4y plus 4y eliminates, it makes 0. Negative 40 plus 60 is 20. So you have negative 10x equals 20. You divide by negative 10, and you get x equals negative 2. Now you go back into either equation, doesn't matter which one, to solve for y. I'm going to go ahead and just take the first equation. So 3x plus y equals 10, but we know x is negative 2. So that's negative 6 plus y equals 10. Add the 6 over, and you get y is 16. So your answer is negative 2, 16. Okay, the systems of equations that we are focusing on in Algebra 2 have three variables. So in this case, it gives us a system of equations, and it says use the substitution method to solve. So when it asks us to do this, we look and we see that I'm going to label these as equation 1, equation 2, and equation 3. Equation 3 is just z equals 4. So we can take equation 3 and we can substitute it into equation 2. And that will let us solve for y. So we have y plus 3z equals 22. But instead of z, we know that z is 4. So that's y plus 12 equals 22. So therefore, subtract 12, and y is 10. Okay, now we have z and we have y. So we can now take and we can plug in or substitute in y equals 10 and z equals 4 to equation 1, and then we can solve for x. So you have 2x minus y is 10 plus z is 4 equals 8. So that's 2x minus 6 equals 8. Add the 6, and then divide by the 2, and we end up with x equals 7. And you write your answers like a point. X is 7, y is 10, z is 4. Okay, on example 3, this is a three variable system again, except you notice that it has more variables. You check and make sure it's in the right order. So you're going to sit here and you see you have all x's in a column, all y's in a column, and all z's in a column, and then equals your numbers. Making sure that order is consistent is important. Okay, so once you verify that it's the same order, and I'm going to go ahead and I'm just going to label it as equation 1, equation 2, equation 3. Okay, we're using the elimination method in a really broad way. So I'm going to kind of make notes as we go of what exactly we're doing. So my first step is I can see that on equation 1 and equation 2, really just all the equations, it would be very simple to eliminate x. I'm pretty confident I can get those all to cancel out. So what my goal is to take a combination of two equations and get x to eliminate, and then a combination of two different equations and get x to eliminate. I'm making new equations that don't have x in them. So with equation 1 and equation 2, if equation 1 is 4x, if I took equation 2 times negative 2, then that would get me negative 4x, which would then cancel out. Let's look at what we're talking about here. So equation 1 is 4x plus 2y plus 3z equals 12. Now, if you took all of equation 2 times negative 2, let's write down what that would be. That would be negative 4x plus 6y minus 10z equals 14. And what I did is I multiplied this whole row by negative 2. Now look what happens. Your x's are going to eliminate, and that's our goal. We are creating a new equation. I'm going to call it equation 4. And the whole point here is that it eliminates x. Now, you didn't have to eliminate x. You could have eliminated y or z. You just look at the numbers and you just kind of decide which one is easier for you to eliminate. I totally could have done the y's pretty easily also. So when I add straight down, I have 8y minus 7z equals 26. Okay, I want to do the same thing where I get a new equation that does not have x in it, but I can't use E1 and E2 again. I've got to use a different combination. So I can use E2 with E3 or E1 with E3. So I think E2 with E3 looks easiest. E2 has a 2x and E3 has a 6x. So I'm thinking if I did negative 3 times equation 2, then that would get me that negative 6x I'm looking for. So let's take all of equation 2 times negative 3. So that's going to be negative 6x plus 9y minus 15z equals 21. And then let's write down equation 3. All right. And let's add straight down. The x's cancel out. We get 8y. Let's see, that's minus 11z equals 18. And we're going to call this equation 5. Okay, so now we have two new equations. We have equation 4 and equation 5. They're now only in two variables, y and z. So we are going to do basically what we learned back in Algebra 1 to solve for the variables. So if I have, let's see here, 8y minus 7z and 8y minus 11z, it seems like making the y's cancel out would be the simplest thing to do. So I'm going to use equation 4, and I'm going to take negative 1 times equation 5. So equation 4 is 8y minus 7z equals 26. Negative 1 times all of equation 5 right here is negative 8y plus 11z equals negative 18. All right, when we add straight down, we're going to get 4z equals 8. Divide by 4, we get z equals 2. Okay, now that we have z equals 2, you can take this z and you can sub it back into E4 or E5, either way, and then you can find y. It doesn't really matter. Let's see here. I'm just going to go ahead and do equation 4. So my next step, that was my third step. My fourth step is I'm going to substitute z equals 2 into E4, and I'm trying to solve for y. So I have 8y minus 7, z is 2, equals 26. All right, I add that 14 over, and I divide by 8, and I get 5. Okay, my last step is I'm going to substitute y equals 5 and z equals 2 into one of the equations I started with up here. It doesn't really matter which one. I'm just going to use equation 1. And that's going to let me solve for my x. So it was 4x plus 2y, y is 5, and then it was plus 3z, z is 2, equals 12. Okay, that is 10 plus 6 is 16. Subtract the 16, you get negative 4. Divide by 4, you get negative 1. So you write it like a point, x, y, z. And that's your solution. Okay, on this one, we're going to do the same thing. So this is just equation 1, equation 2, equation 3. Looking at this, I feel like, honestly, it looks like it'd be really easy to go ahead and get the y's to cancel because you have y, 5y, and y. So I'm going to start with equation 1 and equation 2. And what I'm going to do is I'm going to multiply equation 1 by negative 5. So I get a minus 5y and a plus 5y. So I'm going to multiply for my first step. I'm going to do negative 5 times equation 1. I'm going to add it to equation 2. So I get negative 5x, negative 5y, negative 5z equals negative 10. And then let's write down equation 2. Nothing's changing there. And when I add straight down, negative 5x plus 5x is 0. That makes 0y. That makes 0z. So it's literally 0 equals negative 7. So when all the variables fall out, it's either infinitely many solutions or no solutions. And so because 0 does not equal negative 7, it is no solution. And that's as far as you can go. Okay, go ahead and pause this video and try to solve for x, y, and z. I am going to just kind of let you know, try to eliminate, I think x, because it looks pretty simple. If I could get rid of x, that's the direction I'm going to go. It also looks very easy to do y or z. So you know what, looking at this, actually the y's are ready to cancel out. So pause it and try to eliminate y and see if you can come up with your equation, and I'll come back and show you the answer. Okay, so what I did here was I went ahead and I took equation 1 plus equation 2, and that happened to get the y's and the z's to cancel out. So that was really convenient because it gave me 4x equals negative 4, which just let me solve directly for x. So then I took equation 2 and 3 and tried to get the y's to cancel out. I had to multiply equation 3 by negative 1, so it changed all the signs across equation 3. So that got me my 4x, my y's canceled out. Negative z minus 4z is negative 5z equals 16. So I then was able, because I already knew x, to substitute in negative 1 for x and solve for z. So that got me z. So then I picked an equation. I went with the first one, and I took equation 1, and I plugged in negative 1 for x and negative 4 for z, and I solved to get y equals 3. And then I wrote my answer like a point. Feel free to pause at any point on that if you want to see in more detail what I did.